All right, so I'm gonna go over all of the like basic settings that you need to understand to be able to like 3D print properly. So in Cura, once you're all set up, it is there are these three lines. So if you click this down arrow, then there are these three lines here. This is basically showing you like how many settings you want to see. So if you don't want to be overwhelmed by the all the settings because there's a lot, I usually keep mine on all. But if you don't want to be overwhelmed, you could just click to basic. But just in case you don't know, I'm going to run through all of the basic settings so you guys understand. So probably the most important is layer height. So layer height is basically if we're looking at this is apart from my Killjoy turret project, but if we're looking at apart from the bottom all the way to the top, layer height is basically like what is the thickness of the slice in the Z direction that you want your printer to print at. So smaller layers will basically give like a finer detail and make your part look nicer. So layer height is like all of layer height will change all of these different slices. So a larger layer height means that it will require less layers to slice up your part and it'll print faster, but the quality will be worse. And then the opposite is true. Lower layer height requires more layers, so it'll take more time to print. That is like the biggest contributor to like the quality of your part. And then there's wall thickness. This is like based on your nozzle settings. So I'll go over this a bit later. Infill density. So I usually keep mine at like 15%. This is like a good 15 to 20% is pretty good for like any run of the mill part. Like it'll get you by with 15%. Like you don't need to be printing super high infill. You can save material and you could also play around with the different infill patterns. So I think I just normally have mine on grid, but they have like all these different sorts of infill patterns. So let me explain that to you just in case you don't understand what infill is. So basically in 3D printing, to save time and to save material, the slicing software Cura will automatically like it'll keep a solid outside, but on the inside where like normally it would be like solid plastic, it'll subdivide the part into so you see this like cross hatching. Instead of printing solid on the material on the inside, it'll print like a certain pattern that is depicted by this infill pattern here. And there's all different sorts of ones based on like if you want to like I don't know like have normal or like for it to be strong in like every direction. I think zigzag or there's like a 3D version that like supports stresses in all different areas. There's ones that just like look cool while it's 3D printing, and you could play around with all these different patterns and pick one that you want. I normally just keep it on like default settings and put it on grid. But that's what's going on here. So Curious trying to like give you a depiction of like how it's printing at each layer. So the blue stuff that you see here is the support, and then the red stuff is like the outer wall of your part. So right here it's saying okay, it's going to print two layers, or sorry, it's going to print two walls. Each like perimeter around a piece is a wall. So the red line is the red perimeter is your outside wall, that's one wall, and then the green wall is your inside perimeter. So you get two walls, and that's based on your nozzle diameter. So if you're printing at a zero point 0.4 nozzle diameter, which is like what default is, then your walls are going to be 0.8 millimeters thick because um, that's what this is here. So you have two walls printing at a 0.4 millimeter nozzle laying right next to each other. So that'll be 0.8 millimeters. And then instead of printing solid on the inside to save material and increase speed, it's going to print an infill pattern. And the higher infill pattern that you print at, the more dense or the more amount of plastic there will be on the inside. Unless you're doing something that's like you need a super strong part, then maybe print out a higher infill. Sometimes, like very rarely, I'll need like a really strong part, so I'll just put it on 100%. But otherwise, like you're pretty safe to run at 15 to 20%, and that's like a good way to save weight too. If you need like a lightweight part. What else? Printing temperature. If you're printing at a if you're printing like normal PLA at a at a 0.4 millimeter nozzle, like 200 to 210 degrees C is pretty run of the mill. If you're experimenting with materials, just usually it'll say it on the box, or every manufacturer is different. I'll like recommend different temperature settings. I usually keep my bed at 50 to 60 degrees. That's normal for PLA. I don't really touch print speed. In my experience, like the default is pretty good, and like although you can increase it, it doesn't, in my opinion, it doesn't affect speed that much. Um, in my experience, it like would only really decrease quality. The biggest impactors for speed is like if you can raise the layer height and how many walls you're printing, which I'll go over a bit in a sec. And then support. So I always use, oh, sorry, I skipped something. And then, so retraction. So what retraction is, make sure you have enable retraction and Z-hop when retracted checked. So basically what that is like, so say for instance, the print on this layer, it goes all the way around this. Let's say the nozzle starts where my cursor is. It goes to the left, down, right, up, and now it's got to do a layer on this circle. So the nozzle, if it finishes at this corner, once it goes all the way around, the nozzle will like pick up off the build plate and then like travel quickly, like stop depositing material, pick up, travel quickly to the circle, plop back down, and then start printing again. So in that time, that's what retraction is like stopping the depositing of material, pausing, and then like quickly moving. And sometimes what can happen is like if you don't have retraction, and you just try and like drag over to the next area that you need to print, you'll get stringing, which is basically just like um, some leftover material from the nozzle because it still thinks it should be printing, and it'll seem like spider webby. So this like greatly increases quality, or sorry, retraction greatly increases quality, and Z-hop when retracted also helps too. That'll like pick it off the surface, go to the next spot, and then deposit and move back down. Generate, I always use support, and specifically Cura is great because you can use tree supports. So basically what that is so if you press all and then you go to support, you could type support structure, normal, or tree. So if you see how this is literally kind of like a tree branch. Normal support would here, let me take a screenshot. Normal support would print material like below anything that has an overhang. So probably all of this would get support and all of this. But with tree supports, it tries to do like the math to figure out, okay, what's like the minimal amount of support I need, because like you could print at angles with 3D printing like with no issue. So it's saying, okay, if I do a little base here and then I come up and then I print at sort of like this 45-degree angle, that'll save a lot of material because I don't have to support directly under the areas that need to be supported. We can start combining supports in different branches so they come together. And also tree supports are really great because if you do them the right way, they just like pop off. So sometimes with supports, they'll be like too close to your part and they won't want to pry off. But I love supports. You might have to do, or I love tree supports. You might have to do some fine tweaking to like get it the way that you want. Here, let me see. So this is a big one. If your support is getting stuck to your part and it's not coming off too clean, support Z distance is a big one that you can play with. That's basically modifying the like. So here in the software, it looks like the blue is like touching the red part, but if you zoom in, it's telling the printer to like not actually put them right on top of each other because they're gonna do that anyways. So you leave like a small air gap, and that like decreases the amount of space that it decreases how much overlap the parts have, so your support can just pry off basically. So that's a good setting to tweak if your support isn't coming off too well. And then from there, what else do I use? I'll go back to basic Deselect support. Oh, and then I use rafts. So what rafts are, basically when your printer's warming up, it'll like once you get your nozzle to the point where it can like start to hot enough to start depositing material, it'll like move around and maybe we'll do like a few strokes, just let out some material to like clean the nozzle, make sure it's ready for printing. But after that, I use raft. So raft is basically this like mat. So before my part even starts printing, it's just these couple layers that like form a perimeter around your part, and it's a raft or like a mat, and it's just like sacrificial layers that will like help your part adhere to the build plate. And like a lot of people use glue stick instead of rafts, but it's kind of messy. I like using rafts. I've never had an issue with it. It really helps my parts adhere to the build plate. um what else is there? I'm just go to advanced, make sure I'm not missing anything too important. That's basically the gist. Those are like the probably the most important settings that you'll need to understand. Obviously, from there, if you're having particular issues, you could ask me questions, and then I could help you fine tune things, or you can like go in and experiment. Like, oh, what does changing this number do? Maybe you can figure it out just by the slicer. You can test print it and see how that works. But those are the probably most important settings to go over. Oh, and then the last thing I wanted to show you is so I've made this folder of like modifiers is what I call them, and they're basically just like cylinders, and I have a cube. So I'll show you what I'll just bring in the cylinder. Um and then I'll like resize it and move it to where I want and make it smaller. But the point, so sometimes for my projects, I'll use thread forming screws, right? So what that means is the screws will like bite into the plastic and form their own threads. But to do that, you need enough plastic for the threads to bite into. So let me explain what that means in just a second here once this slices. So for this particular design, I have these like cylindrical holes here, right? And I'll be running thread forming screws through there. So they're going to be biting into the plastic and taking away plastic to form threads. But here, I only have like, what is this? One, two, I have 3 walls at a 0.4 millimeter nozzle. So 3 walls times 0.4 is 1.2 millimeters of material. That's a pretty thin wall to cut to take plastic out of. Like your 1.2 millimeters isn't very thick. So right now, I don't know. I don't think there's a setting where you can just say like, hey, add extra walls to all holes, but there is a workaround. So I'll share these modifiers with you if you guys want to use them in your projects. But the way I do it is I'll drop in a modifier and size it to the like size that I want and position. And then if you click it and then you go to per model settings and then you go to modify settings for overlap, and then I'll just change this to like 6 or whatever. So now it's like, you can see it's sort of like translucent. If you drag it to the position that you want it to, so now anywhere that this cylinder overlaps with my part, it's going to add extra walls. So I'll do that for all my holes where I know I'm using like big thread forming screws that are going to take away extra material. And I'll use those to add extra walls or extra material so the thread forming screws can like take enough material without breaking my part. So now you see the hole has like plenty of walls and plenty of material to take out compared to this one that only has like 1, 2, or in some areas, some parts have only 3 walls, some parts have 2. So that's way thinner compared to this. So doing this like greatly increases the amount of material you can take away. And it's also good for heated inserts that I'll talk about in this course, because that's also going to be taking material away by like melting like hardware into your part. And then built into Cura are support structures. So these are great for blocking material, let's say I didn't want, it wouldn't form material or support here anyways, but let's say these red areas are indicating where support will be. I could put a support blocker here, and then if you left click the support blocker, you could modify it like it's a normal part and like say, hey, don't put support here. And then for whatever reason, let's say you wanted that area of the part to be super clean and like you knew that it didn't have to be supported anyways, even though this would be, I'm just showing you an example. Cura will then know, hey, let's not put support here, and like let's move around that. So if I look at the slicer now, you'll see there's no support here because we blocked off that entire area, but it did put support over here where we didn't put a support blocker. Okay, so in terms of print settings, I'm gonna go over two sets of print settings, and I'm also gonna give you guys my print profiles just in case you have a Prusa Mark III, an Artillery Sidewinder X2, or a CR10S Pro V2. You could just import it and use exactly what I have, but it's nothing too crazy. Like I've tweaked some stuff, but nothing insane. It's mostly the default after you like import a printer into Cura. I'm gonna make this basic just so we're not overwhelmed here. So for I'll go over my Prusa. So my Prusa is my Prusa prints on a 0.4 millimeter nozzle. And I usually print at a 0.2 millimeter layer height. 20 is a little high. I'll usually print at like 15% infill. For a 0.4 millimeter nozzle, you can do anywhere from 200 to 210 degrees for the nozzle. 60 is about the default that I use for the build plate. Print speed at 45 millimeters per second. I use retraction. I also use support. Specifically, I use tree support. So if you go into, let's see, if you go into advanced, and then go down to support structure, you can make tree, and you could copy my settings if you'd like. I also use raft. So basically what that means is when you're printing, instead of printing directly on the print bed, it's going to print like a couple sacrificial layers that just makes like a base that your part can stick to. And that just makes it so that you won't have any issues with your first few layers, and you'll get really good adhesion. So you don't have to worry about your part like flying off the build plate, which I love. But the only issue to worry about there is you have to tune in your rafts so that your rafts are easy to peel off your parts. Because if they're not, then you're going to spend time peeling your raft off of your part. But I've spent some time tuning that. Here, maybe if I go into expert, it'll show my raft settings. So yeah, you can see raft extra margin is like how much beyond your part it's going to extend. Raft air gap is the big one, so that it'll leave a tiny air gap between the bottom of your part and the top of the raft, so they're like easy to separate. So this isn't a good number to play with to make sure your parts are easy to rip off of the raft. And that's pretty much it. Basically, you can fine tune some of this based on like whatever you're experiencing, if you're seeing any issues in your prints. But the other thing I wanted to explain was so for my two CR10S Pro V2s, they're a little bit larger printers, so I equipped a 0.6 millimeter layer or nozzle. So the benefit of that is that I can print faster. Okay, so let's pretend that I have a 0.4 millimeter nozzle, right? And I'm printing at 0.2 millimeter layer height. So the rule is that here, how do I do a text box here? So 0.4 millimeter nozzle. I usually print at 0.2 millimeter layer height, but the rule is that you can, in terms of layer height, at maximum you can go to 80% of the nozzle diameter for your layer height. So if you were printing at a 0.4 millimeter nozzle. The highest you could go would be a 0.32 millimeter layer height at maximum. But in terms of like a balance between speed and fine detail, I think 0.2 millimeters is really good for 0.4 millimeters. And the other thing too is to not go up in always, if you're gonna increase the layer height, increase in increments of 0.04. So right, this is 0.20. If you wanted to increase the layer height, you could try 0.24, 0.28, or 0.32. There's some like magic math that goes on between like the amount of steps in the stepper motors or something like that that I've read that allows for those specific layer heights, the intervals of 0.04 to be more optimal for like printing resolution. So the other thing I want to explain here is, so let's say you're in this scenario, right? And let's say I'm printing like a vase or something. So it's hollow on the inside, but it's got like wall thickness. So if I were printing at a 0.4 millimeter nozzle, you would probably want, so these are called shells, which is basically like if you just had a wall, right? And the inside was hollow. If you just had a wall, right? And the inside was hollow. So like all of this on the inside is hollow. And then you have some wall thickness here. For a 0.4 millimeter nozzle, you probably want 3 roads or 3 shells. So basically to make a wall, it would take 3 passes all the way around. So let's do some math, right? So if you're if you're trying to figure out the total thickness and you have 3 total roads or shells, whoops. So 3 shells at 0.4 millimeter thickness would be 1.2 millimeters, right? So in this specific example, for a 0.4 millimeter nozzle, I'll usually print at a 0.2 millimeter layer height for a balance between speed and, resolution. You could go up to a 0.32 millimeters at the maximum. But if you're printing at a 0.4 millimeter nozzle, you probably want 3 shells or 3 wall thicknesses, 3 passes of the nozzle to create a wall at the minimum. So you want 1.2 millimeters basically total. So I'll show you how to change that. Okay, so here, if you type in wall, so you see how it sort of does the math for you, but it's telling you need 1.2 millimeters total for the wall would be 3 passes. Mine was on 2, but it should be on 3 for a 0.4 millimeter nozzle. You might be able to get away with just 2 passes, but that's usually the norm. But the other thing I wanted to show you was, let me just duplicate this. So this is one of the benefits of having going up in nozzle diameter. So for my larger machines, I use a 0.6 millimeter nozzle. So what's the new 80% rule? This goes up to 0.48. So at my maximum layer height, the largest layers that I could print out would be 0.48 millimeter resolution. Usually I'll print at 0.28 or 0.32. So you have less layers, so your part is printing way faster. And then on top of that, the big time saver is now that we're at a 0.6 millimeter nozzle, we only need 2 shells to get the same wall thickness. Instead of 0.4 millimeters nozzle doing 3 passes for a wall, a 0.6 millimeter nozzle only has to do 2 passes. So think about all your parts that have all these walls around. Let's say you're printing a big part. Not only do you have less layers to print because you can print at larger layers, so it's printing faster up in the Z, but also in the X and Y direction, if you have wall thicknesses, now it only needs to do 2 passes instead of 3. So basically one of these rings would go away, and instead of doing 3 passes with the 0.4 millimeter nozzle, you'd only have to do 2. So you're saving in the layer resolution time, and you're also saving in the amount of passes you do for your walls. So increasing your nozzle diameter can like greatly increase the speed of at which you print, which is pretty helpful.